So if you have 1D motion, things are very easy, right? You just do the differentiation with respect to time on displacement or the distance, you get the velocity. You do the second derivative of the same thing, you get the acceleration, right? What about it in the other way? If you have the acceleration, how you can find the velocity? So we're going to use acceleration is dv over dt. What that means is dv is a dt, right? So we are going to integrate both sides. This will be v naught to v, and this will be 0 to t, right? If v naught is 0, we have the velocity as 0 to t a dt. And remember, in general case, this is not a constant, right? So you cannot take a out from the equation, right? It will depend on most cases on the time as well as the coordinates, right? Any question? And in the same way, we can define equation for S, 0 to t, v, dt. Anything you want to ask? Okay, then let's see what will happen when we go for 2 or 3-dimension space, right? For Cartesian coordinate, both are not very difficult. So let's take directly 3D motion. For 3D motion, again, we need to define a coordinate center and 3 coordinates, right? So one we take as x, a perpendicular one we take as y, and we take another direction z, which will be perpendicular to both x and y. And remember, if you are going to use vector and vector operations, you must define this x, y, z coordinates according to what rule? Are my coordinate systems correct? Because if you want, you can take this side as z. Is it correct? The coordinate system that I have defined. Are the directions okay? X in this side, y in this, and z coming out of the paper, or should it go into the paper? You have to apply right hand rule, right? So remember that the coordinate should follow the right hand rule if you are going to use vector operations, right? Otherwise, it will not work. Then let's say our particle is somewhere here, right? This is my particle P, and we can define its position. So let's suppose it is moving like this. At this instant by x, y, and z. Right? So the particle P is at x, y, z at time t equals t. Right? So now we have to deal with three different distances in three different directions using vector operation. To make our things or make our work easy, we are going to define three unit vectors along each of these directions. Right? What is unit vector? Have you ever used it? What do you call a unit vector? Vectors කරලා තියෙනවද ඔයගොල්ලෝ? Can you hear me?
Unit vector is a vector with a magnitude of 1.
Unit vector is a vector with magnitude of 1. Okay. And what are the vector operations you have studied? Dot product? Yes or no? Vector addition, I think you have studied, right? Then there are two multiplication. One is dot product and the other one is cross product. One is a scalar, the answer, and the other one is a vector answer. Have you studied both of them? Because for this section we don't need it, but when it goes to the study of rigid bodies, you will need vector cross product and the dot product.
We had dot product for our A levels, but we had only the cross production. We only had the definition on that in A levels.
Maybe cross product will be covered at your maths classes, right? When we move into the 3D objects, you may have that knowledge, right? For here, we don't need dot and cross. So what we need is three unit vectors. The one along x direction, I call it as I. One in the y, we call it as j. And one in the z direction as k. Right? I, j, and k. Now, you can define the position of point P, right, as x along y direction plus y along the j direction and z along the k direction. Right? P, or we can say displacement is both are same. And this is a vector quantity. Right? That is our particle at time t. And in the previous section, we saw that the velocity of this particle, again, this time it will be a vector, must be ds over dt, right? Now, get the time derivative of this vector, xi, yj, z. Can you do this? Quickly find the velocity by differentiation xi plus yj plus zk. හරි මොකක්ද answer? Velocity කොච්චරද? So how are we going to do this? We have addition in between the different directions, so we can separate them. D over dt xi plus d over dt yj. I am applying the basic rules of differentiation. dt zk, right? Now you have two quantities, x and I, right? X times I. So you have to use what? Differentiation of two functions, u and v. Then how this should come as x times or d x over dt into I plus x di over dt, and this one dy over dt into j plus y dj into v plus dz over dt into k plus z dk over dt. Is this correct? මොකද හිතන්නේ? හරිද වැරදිද? මෙහෙම කරන්න ඕනේ නැද්ද නැත්තම්? මොකද හිතන්නේ? Okay, Mr. Viraj says it is wrong. Okay. Any other suggestions? Mr. Yasir Vitarana, what do you think? Yasir, are you there? I ask whether what I have written is right or wrong. You should have an opinion. I didn't do anything other than the basic rules of differentiation. මොකද හිතන්නේ? So now we need to see what are these quantities. dx over dt, definitely we know that x gives the position along the x direction, so it is going to change with time, right? So dx over dt will be there into I, right? Then what about this one? X times di into dt. X do change with time, but what about di over dt? Will it going to change with respect to time? මොකද හිතන්නේ? Okay, di over dt is a constant, right? Is it true for all the unit vectors that you can define? Because I wrote it for a specific reason, otherwise I could have just write dx over dt into I. Will it be true for any unit vector? Or in some instances, you need to find the time derivative of a unit vector. But remember, for some instances, you will have a value for this time derivative of a unit vector, right? For this case, it is 0. But that is not true for all the unit vectors. For Cartesian coordinates, ijk, it is true, right? So we can remove this one, then the same thing with dj over dt and dk over dt, right? Once you remove those terms, we have dy over dt dj plus dz over dt into k, and we have a short way to write the time derivative of a distance, right? Which is denoted as x dot. It is called as Newtonian representation. X dot I plus y dot j plus z dot k, right? So this dot represent, you have to take the time derivative of this x. Then can you find the acceleration? Okay. It will be dv over dt. Deshan, what happened? Deshan, you want to ask something? Now find the acceleration by differentiating velocity with respect to time. So this will be v over dt x dot I plus y dot j plus z dot k. Right? Use the same argument as previous, then we will end up with d x dot dt into I dy dot dt into j dz dot dt into k. Right? And again, we are going to write this dx dot dt term in simplified way as x double dot. So x double dot I plus y double dot j plus z double dot. So the double dot represent second derivative with respect to time. So x double dot is really v squared x over dt squared. Right, any questions about these things? So if you do not have any questions, let's see how we can define motion using polar coordinates. In here, we are going to only study about planar motion. Right? We can use polar coordinates for 3D motion, but the formulation is a bit long, and in your level, we only need to see planar motion using polar coordinates. Right? So before moving into study about the motion, let's see how we going to define things in polar coordinates. So we have a point or a particle at point P, and let's suppose its Cartesian coordinates are x and y. Right? And what is the polar coordinates of this particular point? This is r, and the angle is theta. So the polar representation of the same point is r theta. Right? Now, what is the relationship between Cartesian coordinates and the polar coordinates? So you will see that x is r cos theta and y is r sin theta. Right? And we can find theta as what? R is how much? Square root of x squared plus y squared, and theta is tan inverse y over x. Right? This is how you transform something in Cartesian coordinates to polar coordinates, or something in polar coordinates to Cartesian coordinates. Then in Cartesian coordinates, we have two unit vectors, I and j, right? In the same way, we can define two unit vectors in polar coordinates, and typically they are represented as E, R, and E theta. And to make that they are unit vectors, you put a hat on top. Right? So let me draw the unit vectors down here. In Cartesian, you have unit vector I and unit vector j. Right? In polar coordinates, you have the unit vector ER in the R direction and E theta, it is perpendicular to ER. So this will be 90 degrees and this angle is theta. Now, how we are going to before that, when you consider these two vectors, ER and E theta, are they constant? Like I and j. මොකද හිතන්නේ? Unit vectors ij are constant unit vectors, right? There is no doubt about that. They are fixed in direction and also size. But what about this ER and E theta? Will they be going to be the same, or will they change according to the position P of the particle? Right? Our particle is going to move in the real case. So when the particle moves through the space, what happens to this ER and E theta? Are they going to be fixed directions or will they change? So as you can see, since this ER and E theta defined based on the position of the particle, right? At one instant, ER and E theta like this, and when it comes somewhere here, you will see that ER is in this direction and E theta is something like this. So they do change with time. So if you do the same formulation, what we did for this Cartesian coordinates, this time you need to find the derivatives of unit vectors ER and E theta, right? So let's do the derivation of ER and E theta with respect to time. So let's find dER over dt. So how are we going to do that? මොකද කරන්නේ? You differentiate ER with respect to time. So we do not know how to do this directly. What we do is we are going to write ER using Cartesian coordinates. So if you use Cartesian coordinates for ER is what? The dimension of or the size of ER is 1. So 1 into cos theta in the direction of I plus 1 into sin theta in the direction of J. So ER is actually cos theta I plus sin theta J. Right? The same way you can write E theta. How much is that one? That would be minus sin theta I plus cos theta J. Are they correct? This angle is theta, this should be theta. Right? So this is cos theta and this one is sin theta. Right? Now we can do the differentiation with respect to time. So d er dt, we can complete it as d over dt cos theta I plus d over dt sin theta j. Right? When you do the differentiation, what you should get? Differentiation of cos is minus sin theta into d theta over dt I plus cos theta into d theta over dt j. හරිද මම කරන එක? නැත්නම් වැරදිද? You can simplify d theta over dt in the same way as previous, minus sin theta theta dot I plus cos theta dot j. Right? Once we do that, we can take theta dot out. We get minus sin theta I plus cos theta j. Now what is this one? Minus sin theta I plus cos theta j. What is that? මේ quantity එක මේක කලින් හම්බෙලා තියෙනවා. Exactly what? E theta. Can you see? This is E theta and got the same here. So the time derivative of ER is nothing else but theta dot times E theta. Right? Any question on this one? Because this is really important and we need to do it for velocity and for the acceleration. Any question on this one? No? Okay, then your task is to find d e theta over dt. E theta over dt. And tell me what is the answer is. What's the answer?
minus dot
Minus
theta
minus theta dot times what? Minus theta dot is correct.
e minus theta dot e1
ER, not E1, ER, correct. Minus theta dot into ER, right? The vector in R direction. So this should be minus theta dot into ER. Right, now we have the time derivative of E theta and ER. Right. So let's go back to our problem with a particle moving on a 2D plane. So this is my coordinate center O, and unlike X and Y, you can't mark axis here. This is the position of the particle, and it moves like this. At this instant, its position is R theta. R is the vector which shows where the particle is, right? And theta is the angle. So when you define the position of the particle in polar coordinates, it is given by the magnitude R, and the direction of this R is what? E R. That's all. Agree. Displacement relative to point O of this particle P is R in the direction of ER. You don't need two different vectors as in the Cartesian coordinate. Right? Now we have the position vector. Then you need to find the time derivative of this position vector to get the velocity. So that means you need to get d r e r into dt. So do this one carefully, applying the basic rules of differentiation, and tell me the answer. Manish, is this correct? Have you done it? What is the answer for this one? Now, what is the velocity of this particle in polar coordinates?
R theta dot
R theta dot into what?
theta
Do the simple differentiation. So this is two functions. So we need to get dr dt into er hat plus r der over dt.
Sir, we can't see the
Yeah, I'll
screen.
share the screen. Right? Then, as previous case, dr over dt is what? R dot in the direction of er plus what is this one? R and dr over dt is how much? We found it. Theta dot into d theta. So this is the velocity of a particle in polar coordinates. Now, if this particle travels in a circle, what will happen? මොකද වෙන්නේ මේ particle එක circle එක යනවා. මොකද වෙන්නේ? When it traces a circle, r is a constant, right? If r is a constant, dr over dt or the r dot is how much? It should be 0, right? So this part will not be there. And what is this quantity? You should have known this. R in theta dot. Theta dot is really the angular velocity or omega. So what is this? R into omega. Have you used that equation? It is the speed of that particle along the circle, right? Really, it is not the speed. As you can see from here, it is a vector quantity, right? R theta dot into e theta, right? Then the next part, we need to find the acceleration. So acceleration is dv over dt, and that means d r dot pr plus r theta dot d theta over dt. Now carefully expand this. Remember, all of these quantities do vary with time. R, er, theta, all are time dependent variables. So carefully apply the differentiation. You should have d r dot dt r plus r dot r t plus r dt theta dot theta plus r t theta dot dt t theta plus r theta dot d t theta over dt, right? And again we can simplify using the Newton notation. This will be r double dot er plus r dot, and we have der over dt, or the time derivative of er, which is theta dot into er. So this will be r dot theta dot in theta plus this is again r dot theta dot in theta, and this one r d theta dot over dt is theta double dot in theta, and here we have r theta dot d e theta over dt. d e theta over dt is minus theta dot er. Have minus r theta dot into theta dot er. Right? Now we can separate them in er and e theta directions. We have r double dot minus r theta dot squared in er plus r theta double dot plus 2 r dot theta dot into e. Have you got this result? Any difficulty obtaining this? Now, just like in the previous case, if the particle travels in a circle, what will happen? There won't be any r double dot or r dot components. We have r theta dot squared and r theta double dot. What are they? In circular motion. So circular motion, r is constant. Then you end up with minus r theta dot squared in the er direction plus r theta double dot in e theta direction. What do you call these two? This is the what acceleration? This is centrifugal acceleration, and this one is the angular acceleration, right? So all four of these terms have different names. So this one is, by reference to circular motion, is centrifugal acceleration. Right? And this r theta double dot term is the angular acceleration. And what is this term? R double dot is the radial acceleration. And what is this quantity? It is called as Coriolis acceleration. Right? Remember, from this term you can see that you do not need to have second derivative with respect to time to have an acceleration when something moves in a plane. Right? Can you see there is no second derivatives, but still this product of r dot and d dot gives you an acceleration. The only requirement is that you have a angular motion at the same time a radial motion, right? This will be felt when you try to move on a rotating plane, just like you may have ride in a merry-go-rounds when you are a child, and on the merry-go-round you have this theta dot, and if you try to move radially inwards or outwards, you will feel this acceleration. That is why you get the feeling like you are going to fall down when you try to move on the moving merry-go-round, right? So there really is an acceleration, this Coriolis component, right? And another phenomenon which comes with this acceleration is that when you are in the northern hemisphere, you know that whirlpool ගියසුලියක් හැම්බෙලම හැකන ඕන පැත්තට. What is direction of rotation? Sink එකේ වතුර පුරවලා එකපාරට මෝඩිය හරියොත් මොකද වෙන්නේ? Observe that direction. It is always a constant in the northern hemisphere. If you go to the southern hemisphere, like country in Australia, it will rotate in the opposite direction, and that also comes because of the Coriolis acceleration felt by the moving water while the earth is rotating. Right? Okay, we'll stop for here for this week, and let's meet on another session. Are there any questions you need to ask? Get a very good understanding of this accelerations and how you're going to apply them in different scenarios in polar coordinates, right? Do you have any questions? So no questions. Then we'll wind up the session. See you on another day, right? I don't know number of day schools are 4, but that won't be enough. I'll try to arrange another session, right?
Include